Hello. So this is the demo for um, assignment 3 collab D, where I had to write a collab using PyTorch Lightning version for the same 3D player neural network using for a non-linear regression. And yeah, so this is the notebook. So in this, basically I had to use PyTorch Lightning. So I'll just quickly give a brief about what it is. So PyTorch Lightning is a wrapper around raw PyTorch, and that keeps all the flexibility of PyTorch, but takes over the boring part of training. So you can focus on the model and the experiment logic. So the main thing it does is it organizes your code. Um, so your you put your model plus training logic in a lightning module. I have it here. You put your you know the model and the training logic in the lightning module, the forward training step, validation step, configure step, and so it automates the training loop. So earlier we ourselves used to create the training loop for I in epoch, and each epoch it will run. So that is, the trainer object handles the epoch and batch loops, and moving the data models to GPU or CPU, gradient steps, gradient clipping and accumulation, early stopping, checking point, logging. All these are take care by PyTorch Lightning. So it basically makes scaling easy. So you don't have to look at these small things. You just you work on your logic and just get it the output away with you. So yeah, that is the difference. So yeah, I'm using the same data over here. I'm the same sign of 2 pi x plus some noise. So this is how the data looks. And again, I'm using the Todd's linspace and sign the formula for getting the data. Once that is done, excuse me, I am this is the data loader. So the data loader is used for more efficient, to make your code more efficient. Let me just go through my notes. Data loader. Yeah, so it automatically creates the batches and shuffles your data. So you don't have to do that, so here I'm just passing the batch size, shuffling. So it makes um, you know, it allows you to have the batches running in parallel. So it takes care of the parallel for you. So yeah, then we are using the lightning module. So in that, uh, yeah, here you can see the lightning handles the backward and the optimizer dot step, which is updating the gradients step, that is handled in it. So it is same as using the PyTorch. We used to use nn dot module over here. We are now using the l dot lightning module, and here we are initializing our variables. So I'm just saving all the parameters over here. Then I'm doing this creating this net, which is a sequential neural network of, I'm calling it this linear layer, then an activation, then linear activation, linear, and this is the loss I'm going to use. And once this is initialized, this is in the forward I will just call my neural network the sequential model. And this is my this is the differentiating step. I'm defining my training step over here, so I don't have to write the loop over there. And excuse me, sorry. So here I am just creating my batch for x and y, and I'm getting my predictions from in y hat, my loss. And so here it is just calling uh, So here, where is that? Let me, yeah. So the predicted values are stored in y hat. Then I'm calculating my loss, and uh, yeah. So so for each, it actually logs your output in a CSV, which we will see. It will log your output, and then configure optimizer is, to is the gradient which we are going to call, and the parameters required for it. Once that is done, outside the module, I'm just creating this instance, and then randomly generating the values. And yeah, this is just for sanity check, sorry, my bad. Now let's train the model. So I'll just create as I earlier mentioned, that the logs are logs are properly stored, and you can also see the progress bar. And yeah, so it's actually very useful when you're saving your best model, reusing from checkpoints, etc. So you can actually look at where are my losses going down, going up. So if you want more analytics on top of it, you can use this one. So yeah, here you can see in my logs it has created. So I ran it twice, that's why it has this. So here you can see this metrics.csv. There you can see that at this epoch 1, this step, this was the training loss. Epoch 2, epoch 1, 13th step, the training loss, like that. So this is just the 10 pages, but this is how it stores your loss per step over here. Now so we are creating a model here. Once the model is created, I'm just creating the trainer instance. I'm just calling l.trainer, and I'm passing the values to it, the epochs, the logger details, log every steps. So it's 1, so every 7th step is recorded over here. Then enables progress bar, which is when it was running, I could see the progress bar very beautifully over here. Then we have accelerator. It is only when you are using GPU. In my case it was true, so yeah. And enable checkpoint. Then we call trainer.fit, which is where it will take the data loader and your module, and it will do the training in the background. So you don't have to take care of that loop which we used to create, and see the back propagation happening. So, and we are logging the output in the CSV, which I just shown you, and this is the hyperparameters. Yeah, you can also see it over here. Yeah, so that is pretty much it. And here I'll just plot the loss. So it every as the epochs are increasing, the loss is also decreasing. This is again we are plotting from the matrix CSV. So here you can see the few ups and downs, because in the earlier notebooks you could see a very plain graph, but here you can see very detailed, because at every 7th step the values are captured. So yeah, this is the prediction versus ground truth. So the blue dots are the original data, and this is how red is how the model has predicted, and which is very much similar. So yeah, that is pretty much it. This is actually showing how to reload from a checkpoint. So you just give the checkpoint, and it will go ahead, and in your data it will find out and give you the output to it. So yeah, that is pretty much it in this notebook. Thank you.